Hello students, today we are going to see some more interesting and important questions from MS Chouhan's Organic Chemistry Isomerism Level 1 and the question from 171 to 180. Come on, let us discuss the first question. Which structure is most stable among these? Right, now let us check the same kind of question. We have gone through question number 98. Question number 98 also we have gone through this kind of question. Concept is same only thing questions are different. So generally, as we observe, keto group C double bond O here, you see here C double bond O, which is greater than C double bond C, right? Now this concept you know very well, okay, because electron withdrawing group which is present over here. Now here in that amount which is most stable, let us check. So here in this point, two keto group it is available. So here two keto group means electron withdrawing group. Actually, this is what it is, electron withdrawing group, both the side. In between here, active methylene group is available. So active methylene group, actually what it is, two hydrogen is available. So this is acidic hydrogen. So acidic hydrogen ready to donate that proton, what it is, by the base. That means base is ready to remove this hydrogen. So what happens here, that structure, so here double bond O, here also double bond O, here one hydrogen, here one hydrogen. This is what active methylene group. Now what happened, this proton which is donated over here, so resonance takes place. So you will get the structure in this way. Okay, so you will get that double bond, and here one hydrogen is available, here one oxygen, right, single bond oxygen, and here this hydrogen which is going to attach over here. This C double bond O same as it is. Now hydrogen and oxygen in between, what happened here, intramolecular hydrogen bond takes place. Molecular hydrogen bond, right? So intramolecular hydrogen bond, actually it is a six-membered ring. Now you see, 1 2 3 4 5, six-membered ring. Now first point, it is more stable because of intramolecular hydrogen bonding. Second point, what happened, continuous conjugation takes place. Continuous conjugation means this is a lone pair of electron. Lone pair of electron transfers over here, then it transfers over here, and it is transferring, then again it comes here. So like this, it is continuous conjugation. So second point, what it is, continuous conjugation effect. Conjugation, right? I hope you got the clarity. First thing, what it is, here you're getting intramolecular hydrogen bond, that is actually it takes more stability, and the continuous conjugation, that means it is resonance point. So that is also another point, it is more stable. Which is more stable? Enol is more stable. So in this option, enol is more stable than keto, right? I hope you got the clarity. Why enol in this form? Always it cannot be keto is more stable than enol, but sometimes according to that structure, enol is more stable than keto. What are the reason for it? First and foremost, intramolecular hydrogen bonding. Second thing, continuous conjugation. So continuous conjugation in the sense, enol form gains more stable due to resonance. So that is a strong keyword. So due to that resonance, enol form is more stable than keto. I hope you got the clarity. What is it? Active methylene group. I hope you got that clarity. Here actually what it is, acidic hydrogen is there. So acidic hydrogen ready to donate that proton. So in that way also it is more stable. Okay, now in the structure, which is more stable? A, B, C, D. So according to this, here what it is, hydrogen is there, no, that both the thing, actually what it is, here both the thing, intramolecular hydrogen bonding, six-membered ring, and angle strain is nil. Actually, angle strain nil means, see, generally like 90 degree, 30 degree means angle strain will be there. But this is what it is, actually six-membered ring, angle strain, it is nil. Okay, so angle strain, what it is, higher angle strain, lower stability. So in that way, here enol content is directly proportional to acidic strength. One more point also I just wanted to mention, enol, it's directly proportional to acidic strength. Right, I hope you got the clarity. Now, which is the correct option? Option C is the correct option. Why option C? It's the correct option. First and foremost, intramolecular hydrogen bonding. Second one, continuous conjugation. And angle strain, it is nil. See, these are all the main important points. So one more point, enol, it is what it is. Enol content, it is directly proportional to acidic strength. Active methylene group, and mainly it is resonance. Resonance is there, means that point it will be more stable. So option C is the correct option. Okay, come on, let's go to the next question. Next question, identify conformer of 2-methyl pentane. Now, as we observe this, Let us find out that formula so that it will be easy for us to identify the answer. So generally, this is a dot, this is a circle. So dot and circle here in this point, round circle, it is a back carbon, right? Back carbon, and dot, it is a front carbon, right? So that is the way we can identify. This is a dot, right? Front carbon, CH3, CH2. Back carbon, CH2, CH2, CH3. So in that way we can identify. So option A. So here CH3, this is CH3, CH2 and CH2, CH2. Back carbon in this middle point carbon it is CH2. Here down CH2, CH3. So this is option A. Option B, I hope you got the clarity. How do we identify? Option B, now this is dot front or no. So this ET, that means ethyl, it is CH3, right? You got that idea? And here next one, what it is? CH2, CH2, CH3. CH2, CH3. Right now, option C, what it is? Here, what? CH3, CH2, CH3, CH2. Here, what it is? CH2, CH2, CH3, right? CH2, CH3. Here from here, CH3, right? So here one more hydrogen, actually it is there. Okay, hydrogen. Right now, option D, what it is? Option D here. Option D here, as we mentioned here, CH3, 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 CH, CH3. Right, now next one, what it is? CH2, ET. What it is? ET here, this point ET, right? Okay, ethyl. Right, now what is the correct option? So which is that what they are asking? 2-methyl pentane. So 2-methyl pentane. So this is 1, 2, 3, 4, 5. Pentane it is there, but not 2-methyl. And here also 2 carbon is available, right? Ethyl means 2 carbon. 2, 3, 4, 5. So 2-methyl pentane. So that means here already 2 it is there. That means this is the third carbon. Right now here 1, 2, 3, 4 only it is available. Butane. And here 1, 2, 3, 4, 5. This is 2 is there. 1, 2, 3. Here 4 and 5. Why 4 and 5? Ethyl, 2 carbon it is available. So 2-methyl pentane. Yes, option D is the correct option. I hope you got the clarity. How do we identify? CH3, CH, CH3. Here CH2, CH2, CH3. Combined together, they mention ethyl, right? I hope you got the clarity. How do we identify the option and correct answer in this point of this question? Right, come on, let's go to the next question. Now, which is the correct option? Option D is the correct option. D is the correct option, right? First energy conformer of. Okay, now let us identify which is the correct option. So generally in this question, staggered form, it's more stable than eclipsed form. Staggered form, why it is more stable, you know? Because less repulsion, right? I hope you got the clarity. So staggered form, it's more stable, due to less repulsion. Right, I hope you got the clarity. But eclipse to form, due to that, what it is? Repulsion will be more because behind another group will be available. So naturally, what it is? Repulsion will be more. So repulsion more means less stable. So less stable means more repulsion. More stable means less repulsion. Just the opposite. I hope you got the clarity. Now, in that among, which is staggered form, here CH3 it is there. Now I just mentioned here CH3 it is there, hydrogen, and here hydrogen, here cyclohexane. So cyclohexane and methyl group, like both are more or less same kind, right? Alkyl. Right, now in that point here CH3 is there on the top. What it is there on that behind cyclohexane it is there. So that means this is 100% alkyl one behind the other. So that is it is opaque, like both are hiding each other. So that means this is eclipsed form. So this point it is actually eclipsed. I hope you got the clarity. Eclipsed. Now, whereas here, this point, CH3, here hydrogen and here hydrogen. So this is a staggered. This point, it is staggered. But here, hydrogen, CH3, where it has gone, this is not at all applicable. And here, CH3, they didn't even mention two CH3, only one CH3 and two hydrogen, just to the opposite, these two. Now, which is exactly correct means option B is it correct, because it is a staggered form, as they mentioned this. Lowest energy, actually, energy it is low means stability will be more, energy less. Why that energy less? Because what it is, less repulsion. So less repulsion, more stable, and the lowest energy. I hope you got that idea. Come on, let's go to the next question. Atoms will be present bisect during plane of symmetry. So in that molecule compound, how many atoms are present? will be bisect. You know what do you mean by bisect? Bisect means actually two equal parts you will get when you cut. Okay, bisect. Bisect means two equal parts. Two equal parts. Right. So two equal parts when you cut. So that is a symmetrical way also we can say. Ek maar do dukda, like that way. Right. Now come on. Let us check with that. How many atoms are present in this? So here wedge chlorine, here dash chlorine. And here in this point, you will get what it is. Dash hydrogen, because cyclobutane, no, so two CH2 is there, no, so here wedge hydrogen. Okay, I'll draw the structure for you to understand. Here what it is, cyclobutane. So above and below, like wedge and dash, no, above the plane and below the plane. So hydrogen and chlorine, here chlorine and hydrogen. So when you cut this compound, that means equally, you will get what it is, intersect, like a bisect. So you will get what it is, how many atoms are present. So how many atoms will be present? Here chlorine it is there, here carbon it is there, here hydrogen, and again one more thing, here hydrogen, here carbon, and here chlorine. So 1, 2, 3, 4, 5 and 6. So 6 atoms will be available. Even I can draw that planar structure for you to understand. So here even this side also 1, 2, 3, 1, say 1, 2, 3, 4, 5, 6, like that. Here 1, 2, 3, 4, 5, 6. So 6 atoms. 6 atoms will be available. I hope you got the clarity. When you cut equally, equal parts, when you cut this side, it cannot be possible because one it is upwards, one it is downwards. But here when you cut this side, 1, 2, 3, 4, 5, 6. So which is the correct option? Option C is the correct option. You know how do we get it, and you got that idea. What do you mean by bisect? And the next one, the number of all types of chlorobutane. It's very simple. Chlorobutane, you know what is the formula of chlorobutane? And all types of what it is, isomer they are asking. Okay, now here CH3, CH2, CH2, CH2Cl. This is chlorobutane. This is one. And the second one, what it is, all type of isomer they are asking, right? Okay, let me write that another formula. CH3, CH, CH3, and CH2Cl. Right, now third one, what it is, here CH3, CH3, CH2, CH2, here CH, Cl, CH3, right. Fourth one, what it is, here CH3, CH3. I hope you got the clarity. CH3, Cl. Okay, now this is chlorobutane, 2 methyl, what it is, 2 methyl, second group methyl, is formula. This is one isomer and this is the second isomer and this is a third isomer. Third isomer, there will be two. Why? You know, this is a chiral molecule. Why? Because 4 different groups are attached to this carbon. So this is a chiral compound. So RS configuration will be available. And this is fourth isomer. Okay, that means a 4. This is 3, 4, 5. I hope you got the clarity. 1, 2, 3 and 4, 5. So how many isomers it is possible? 5 isomers are possible. Isomers. Right. Why this is 2? RS configuration. How do we go for RS configuration? Chiral compound. This carbon, which is attached with this side and this side, here Cl, here hydrogen. Next one, this side CH2. Here this side CH3 and this side CH2, CH3. Right. Now this point which is attached over here. Now this point which is attached to this side, and here chlorine, and this point hydrogen. So chiral. Here RS configuration. So anti-clockwise, clockwise. So in that way RS configuration. So this is a chiral molecule, right? Okay. So how many isomers are possible? 5 isomers are possible. I hope you got the clarity. Come on, let's go to the next question. So fifth answer, it's correct, right? I mean 5 isomers are possible. Right. Next question. Pairs of compounds are not positional isomer. They are asking not positional isomer. Okay, here this side OH and CH3, and here CH3OH. So that means here 1, 2, 3, and here 1, 2, 3, and 4, and here 1, 2, 3, and here 1, 2. So that means this is also these both pairs. No, this is actually positional isomer, and this is also positional isomer. Yes, CH3 OH, CH3 OH. So the numbers have changed as I mentioned. Now here CH2 OH, here OCH3, totally different functional group it is there. This is alcohol, and this is what it is, ether. ROR, ether. This is benzene, OCH3. Okay, so that means this is actually functional group. Alcohol, ether, it is a functional isomer. Functional isomer. Okay, so that means it is not a positional isomer. So all of this it is not possible. Okay, so that means this is first option A, it's not possible. Option B, it's not possible. Why? Because it is belonging to positional isomer, which is not positional isomer. This is a functional isomer. So functional isomer will not be the positional isomer. So which is the correct option? Option C is the correct option according to this question. I hope you got the clarity. This is alcohol and this is ether. So this is a functional isomer. This is not a positional isomer. So position has changed. CH3OH here. CH3OH, the position has changed. Whereas functional group, same molecular formula, but different functional group. That is called functional isomer. I hope you got the clarity. Come on, let's go to the next question. These are all very simple, easy. Chiral carbon atom. Yeah. N-butyl alcohol, isobutyl alcohol, secondary butyl alcohol, tertiary butyl alcohol. Okay, this is very simple. Let me write it for you to understand. Here, option A, CH3, CH2, CH2, CH2OH. So this is what it is, N-butyl alcohol. Option B, here, isobutyl alcohol, CH3, CH, CH3, CH2OH. This is isobutyl alcohol. Option C, here, CH3, CH2, CH, CH3, here OH. So that means, yeah, this is secondary butyl alcohol. Option D, here tertiary butyl alcohol. This is very simple. CH3, C, CH3, here CH3, OH. So in that, which is having chiral carbon, see there is no chiral carbon, long chain structure. So this doesn't have. And this one, carbon which is attached to CH3, same group is available. This also not chiral carbon. Chiral carbon means 4 different groups or atoms attached to that carbon. So that is called chiral carbon. So here in that C, carbon which is attached with hydrogen, OH group, CH3, C2H5. So that means 4 different groups. Carbon which is attached with here OH, here hydrogen, here CH3, here C2H5. C2H5, that is ET, I just mentioned, ethyl. I hope you got the clarity. So 4 different groups are atoms attached to carbon. So that is called chiral carbon. So option C, it's a correct. Let me check it this. So this is same only. So everywhere same. This is only different. So this also it's not correct. So option C is the correct option. This option C is the correct option. I hope you got that clarity. Now come on, next the pair of enantiomers among the following compound. So pair of enantiomers, here 1, 2, 3, 4, here 1, 4, 2, 4, 3, 2, 3, and 1, 2. Okay, let us check with it. This is really interesting. Yeah, I just wanted to mention here clearly. So fourth priority. So fourth priority according to CIP rule, fourth priority, already I have mentioned in second video, but still every time we are mentioning now will be understand this concept very clearly. So clockwise yes, anti-clockwise are, right? Now and the same way, fourth priority on vertical downwards, clockwise are and anti-clockwise yes. Come on, let us check that compounds and we can find the pairs. Okay, RS configuration. In that priority order according to this here and this point, 1 priority 1 bromine, right? This is 1 and this is 2 and this is 3. And of course, this is fourth priority. So whom you will give the priority order? So fourth priority is in horizontal. Clockwise it is coming. So clockwise means what it is? Clockwise means yes. You just check it, yes. So this is yes configuration, right? And the same way here also. 1, 2, 3, and 4. So fourth priority comes this side. So 1, 2, 3. This is also clockwise. So this also yes. I hope you got the clarity. So both A and B are clockwise only. Now let us check this one. 1, 2, 3, and this is 4. Fourth priority in vertical. So fourth priority on vertical, clockwise or anti-clockwise. Let us check here. Fourth priority on vertical, clockwise means or, anti-clockwise means yes. Okay, now I think you got an idea. Now this is clockwise or anti-clockwise. So here 1, 2, 3, 4. So that means this is clockwise. So for third group it is R. And the next one here, first priority, this is 1, bromine 1, and this is 2, this is 3, and this is 4. So this is anti-clockwise. So anti-clockwise, vertical anti-clockwise means that is yes. Okay. Now first one yes, second one yes, third one R, and fourth one yes. So let us have the pair. R is configuration. 3 and 1, 3 and 2, and 3 and 4. So these are all 3, actually third compound it is R. Rest of that and all yes. This 1 and 2 and 4 yes. So that means 1, 3 and third and 1, third and 2, third and 4. So in that option which is correct, third and 2, that means 2 and 3. Yeah, option C is the correct option. Hope you got the clear idea about RS configuration and how to identify and trick of the CIP rule, fourth priority, horizontal and fourth priority vertical, just to the opposite. Hope you got the clarity. Come on, let's go to the next question. Which of the following is chiral? Cell phone, spiral staircase, scissors, and all of these. One pair of scissors. I just brought that, what it is, picture for you to understand. Here, cell phone. Cell phone, how come it is possible to get as a chiral? See, chiral means four different groups or atoms attached to that carbon. That is called chiral. So, in that way, A, B, here C and CC, no? Here D and E. So, four different groups or atoms attached to that carbon. That's called chiral. Okay. So, in that here phone, as we are looking at that phone, it looks like symmetrical, but no, one side switches will be there, the other side here actually what it is, earphone point will be there, here charge point will be there, here nothing it is there, so this is center point. So that means four different groups are atoms attached. That, see what a question, simple idea only, but it is really what to say, day to day in our regular life we can see that chiral, this might be a chiral, so like physical activity easily we can make out. Next one, staircase. So spiral, so here in that spiral point here, this side one, this side one, and this side one, and this side, so it is different corner like east, west, north, south. This is the center, so naturally this is also chiral and this is also chiral. And a pair of scissors, this is different point and this is different point, and this, see here it is joining both, it is something different, you see, and this side you see that shape, and this side you see the shape, something different, so that this also chiral. Okay, now I think I have given that idea. So all of these only I can give you. Now I wanted to give some more idea about chiral. So here, as you are showing your hands on the mirror, so your mirror shows just the opposite. So the hands chiral, non-identical mirror images. So this is like a round ball which is showing on that mirror. This is a chiral. A chiral means it looks like alike. Okay, so this is a chiral, and this is chiral. Chiral means different groups or atoms. You see, this is just a non-superimposable mirror image. And the same way, enantiomers also the same. Just it looks like on the mirror, a boy is showing on the mirror how behind and front side like. So these are all the physical point you can day to day in our regular life we are seeing. So this also we can compare and we can learn. Suppose sometimes the question also comes in that way, whether this is enantiomer or not. Okay, now next to one here, fruit salad. So this is what to say, fruit salad, different fruits are combined together which is attached in that, so that is also we can say it's a chiral. Okay, now here a chiral object. So a chiral object, how can we identify a chiral object? You see, both are, it's a mirror, both are left hand and right hand, one upon the other, so one upon the other cannot be superimposed, whereas here right and left, this bottle can be superimposed. So these are all the ideas. I think I have given enough of points for you to understand chiral, a chiral, non-superimposable mirror image, superimposable mirror image, enantiomers, chiral and achiral. I think I have given enough of points for you to remember. Yes, come on, let's go to the next question in our next video. And thank you for watching.